Hello again. We're continuing on fractional exponents, and this time instead of doing 1 over 2 or 3 over 2, our denominator in our fractional exponents are cubes, or it's 3. Basically what that means is that all of these are cube roots to an extent. So if I want to transpose or look at this differently, although I would recommend that you just solve it in exponential form as opposed to root form. So this is cube root of 27 to the first. Now maybe some of you actually know what the cube root is, and that's fantastic if you do. If you don't though, it's a little bit of a problem. Now this one reads cube root of 8, and when we're working with a negative exponent, what we want to do is we want to put parentheses around it and take care of the negative last. It just makes a little bit more sense. Actually, you know what, I should probably write that. A little bit off to the side. When I'm working with negative exponents, you put parentheses and then you take care of the negative last. That's what I would actually do. And then I got 64 to the 4/3. If I wanted to write that, that's the cube root of 64 to the 4th power. And this one is cube root of 125 to the negative 2nd. And students sometimes ask me because they want to stay in root form as opposed to exponential. And you're going to do what you're going to like better anyways. And they say, well, do I do the cube root 4th or do I take 64 to the 4th? And the answer is, it doesn't really matter which one you do first, as long as they don't come out as decimals. Will it be easier one way or the other? And the answer is, it just depends on the problem. I wish I could say, yeah, you always take the root before you power, but that's not always true actually. So you got to consider that. But I'm not going to solve these in root form because we're not actually working with roots right now. We're working with exponents, and I want to stay on that subject. But later on, you'll be given cube root problems or 4th root problems, and I will solve them with roots. But I actually always like exponents better. So if I split 27, and I'm going to skip a couple steps a little bit into this now because I'm going to assume that you can follow along. If you can't, watch the first lesson again and watch how I do it. So I'm going to split the base of 27 into 9 and 3. I'm going to split the 9 into 2 3s. So 27 is actually 3 to the 3rd power. And it's all taken to the 1/3. Now by skipping steps, here's what I mean. I'm not going to tell you 3 times 1, well I am, but I'm not going to show it. 3 times 1 is 3, 1 times 3 is 3. So it's 3 over 3. When I multiply these two fractions, it's 3 over 3, which is 1. So it's 3 to the 1st, which equals 3. So when you multiply these two fractions, it comes out to 3 divided by 3, and 3 divided by 3 is 1. 3 to the 1st is 3. Same thing here. When I have 8 to negative 1/3, I split it, and I only take the primes into consideration when I do the bases. This actually works very well when I do stuff like logarithmic form, which is a little ambitious, but we're going to get to that later, not now. You might ask yourself, what's a log function? Let's focus on this right now. So 2 times 2 times 2, it's 2 to the 3rd, and it's all taken to the power of negative 1/3. When I multiply these, I get 2 to the negative 1. 2 to the negative 1. That's been a bad exponent. Go downstairs. Take your 2 with you. I don't got a placeholder. It's a 1. I'm not going to write 2 to the 1st. It's just 2. I do have students who write 0.5 and then they realize 0.5 is a half and they get away with it. Yeah, I understand when you do that into your calculator because you don't feel comfortable. You know, and people ask, are we ever going to use this in real life? I say, you know, it depends on your job. Probably not, but you know, doing math is a good key to complex learning. That's basically it. It helps you formulate ideas and reason better. That's probably the best idea. I mean, I've met people, never mind. I probably shouldn't continue with that. It really does help the way you think. It doesn't mean you can't be smart if you don't know math, but it's like, you know, it's like taking protein shakes and doing push-ups. It just makes your mind stronger.
Santos, please dial operator. Jason Santos, please dial operator.
I know that's happened in one of my lessons before. Happens from time to time. So I've got the cube root of 64 to the 4th power. What I'm going to do is I'm going to split 64. And when you make a factor tree of 64, and again I'm running out of room here, so I'm just going to tell you what it is. It's 2 to the 6th power. So 64 is actually 2 to the 6th power. And you can check it too with a factor tree, which is the same thing as 6 over 1. And it's taken to the 4/3. That's the same thing as 2 to the 6 times 4 is 24. 1 times 3 is 3. 24 divided by 3 is 8. Which comes out to 2 to the 8th, which is 4, 8, 16, 32, 64, 120, 256.
May I have your attention, please? IT department, please dial operator. IT, please dial operator.
I guess this is the lesson of interruptions on the overhead. Speaker, pardon. This one is 125 to the negative 2/3. So I'm going to split 125. And when you split it, it comes out to 25 and 5, and you split it, like I said. 125 is actually 5/3. Well, how do you know that without doing it? I just do this a lot, and you get better with it. And I promise you, if you do it a lot, you really will get better with it. And I didn't really get super good in this until I started teaching, because I had to know it all the time off the top of my head. So this is 5 to the 3 over 1, and it's taken to the negative 2/3, which is the same thing as 5 to the, that's negative 6 over 3. What's negative 6 divided by 3? It's negative 2. You've been a bad exponent. Go down. And take, that person that you made bad with you. So that's 5, and you need a placeholder of 1. I don't have any room. So what's 5 squared? What's 5 times 5? It's 25. Now, students go ahead and they put this in their calculator and they get 0.04, and they expect their teacher to mark it right. Probably not going to mark it right, because I wouldn't. Especially when I say, no, I want it as a fraction. So make sure you always put it as a fraction. So that's our second installment of fractional exponents. This is really cool because it's like the border of simpler math to the extreme of more difficult algebra, actually. So with that said, we're done for right now. I'll come back and clean this up in terms of fractional exponents. But for right now, have a great day.